Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we'll continue to learn about time in Pandas. Here we'll look at how to work with pd.offsets in much more detail and look at additional functionalities associated with it. And we'll also look at how we can normalize dates to midnight, and let's see how that works as well. Before moving, I just want to share this slide where these are the various ways you can change the time when we are using pd.offsets. So among all these items, we'll be looking at only the blue colored items in this video, and in following two videos we'll look at few other items from here, so that it'll give you a general idea of the extent to which we can use pd.offsets and how it can help us work with time data. So let's get into Jupyter Notebook and start coding. Here I've already created a new notebook and imported three libraries: NumPy, Pandas, and DateTime. So the first item that we'll look at is how to read timestamps. So I know we have already looked at this in detail earlier, but there is a slight variation that I would like to talk in this particular section, and that is the zone that is with the time. So let's create a time pd.timestamp, and here let's get 2020.02.01.00.0000, and here I'm gonna put this time zone of US Eastern. Now when we print the value of X, and when we print the value of X converted to UTC, so we are changing the time zone from US Eastern to UTC in this last line. Here, if you notice, there is a minus 05:00 in front of the timestamp, and what that tells us is that this particular local time, US Eastern time, is 5 hours behind the UTC time. So if we want to create UTC time from this local timestamp, what we need to do is add 5 hours to this, and that's what we did here when we converted it to UTC time zone. So basically the date is same, 2020-0201. However, we have changed the hours from 00 to 05, and that 5 comes from this particular part that is placed after the negative sign, and then this part becomes 00. So just wanted to share that with you because we may talk about that in upcoming videos. Now let's look at what's the difference between pd.Timedelta, so pd.Timedelta, and pd.DateOffset. Both of them, they do similar perform similar tasks, except there is a subtle difference in that time delta. So let's try it here. So what time delta does is it changes by hours, okay, and what date offset does is this particular, it accounts for daylight saving time. And what daylight saving times is, if you do not already know, it's changing the resetting the clock by 1 hour, either forward or backward, depending on what time of the year it is, so that you get the maximum daytime available. And for example, in November, the clock is set back 1 hour. Okay. Now the date offset works in the same way, except it, in case of daylight savings time, it does not account for that. So if we are changing the date which happens on a daylight savings time change day, then it will just create a new date which is the same time next day. It will ignore the daylight saving time, so it creates same time next day or the day that is specified, and this will become clear in this example. So let's create a variable x with timestamp of 2020-11-01, then 000000, and TZ, which is the time zone. I'm going to put US Eastern. Now this is the timestamp right here. If we use the time delta, so pd.Timedelta, and if we add day 1 day, what we get is we did not actually add 24 hours here. We added only 23 hours. And the reason is because of daylight savings time, the clock was moved 1 hour back in time, and therefore we just have 23 hours here. And if we use the date offset, so pd.DateOffset, and again if we type days is equal to 1, in this case we advanced complete 24 hours, so the date changed from 01 to 02 and the hours are 00. So that's the difference to keep in mind when working with either date offset versus time delta. So both, if the date is not which falls on a day where the daylight saving times is taking effect, then it doesn't make a difference. So let's say if we change this to November 5, and now if we run this, both of them work exactly the same way. You see, they both change 24 hours in time. So that's one difference I wanted to share here while working with time delta and date offset. Next, let's look at how we can use pd.offsets to work with business day. So pd.offsets.BusinessDay, BDay. And for this we'll again create timestamp. X is equal to pd.timestamp, and the date we are going to specifically choose is 11 let's say it's 17th of July, and 000000. Now when we look at X, this is the day we have, and we look at the calendar. I've already created these. So the 17th of July, it's a Friday. So if we are looking to increase, if you are looking to add go to the next business day, it's going to be the 20th. Okay, and if you are looking to go to the second next business day, it's going to be the 21st. So let's see how we can get that right here. So X, as we already looked, we can also type a command and check what the day it is. It's a Friday. And if we create a new variable Y, and to this we are going to assign this value X plus 2 into pd.offsets with a S dot BDay. And now if we look at Y, we see that we have advanced to the second business day. If we just had 1, then we would have gone to 20, which is the next business day, because Saturday, Sunday is a holiday, then 20th. If we add 2 right here, then we go to 21st, which is the next business day, which is a Tuesday. Again, here we can look at the day also. So X dot day underscore name, and here we see that it's a Tuesday. Next, let's look at how we can add years. So I'm gonna create another timestamp. X is equal to pd.timestamp, and here the day is 2020-07-20, and then 10 20 30.001.001.001. Now we look at, this is the timestamp we have here. If we use the pd.DateOffset, this is how it will look: x plus pd.DateOffset, and here we can add years, so years is equal to 1. And as you can see here, we added a year, so from 2020 we now have gone to 2021. The rest of it stays the same. At the same time, we can also use YearBegin, so s plus pd.offsets. Here there is a s dot YearBegin with a capital Y and B, and when we run this, here we can see that we changed the year, so we did go to 2021. However, using YearBegin, what we have done is we have moved to the beginning of the next year, where we have the day and the month changed. So we now have gone to January 1st of 2021. The hours and the minutes, the time stays the same. However, we have changed the date of that particular timestamp. Now let's look at a couple more variations of this. If we use date offset for hours, so I'm gonna type right below this timestamp because we are going to use that now. So if you type x plus pd.offsets.DateOffset, and here if you type hours is equal to 1, what we are doing is adding an hour to the timestamp. So here we have the hour is 10. Now we have changed it to 11. Rest of the timestamp stays as is. After this, we can go ahead and add the hours in another way also. So let's look at alternative method. If we type x plus pd.offsets.hour this way, without using this date offset, we just specify .r. Then if we specify 1, we get the same output where we added an hour to the timestamp x, where it was 10 hours, now it's 1100. And instead of 1, we can go ahead and add any number of hours. So we can add 2 hours, for example. So we went from 10 to 12. Apart from hours, we can also add nanoseconds. So there is plenty of variation we can use. So x plus pd.offsets.Nano, and here if we type 1, what we are doing is adding 1 to the nanosecond, so the last digit in the timestamp. So from 1 it now has gone to 2. So those are the variations in which we can work with time in the timestamp. Now let's look at couple more, use nano and microseconds using date offset. So x plus pd.offsets.DateOffset, and here if you want to change microseconds, and if you want to add 1 microsecond, so what we are essentially doing is changing this 1 to 2 right here. So we used the microseconds is equal to 1 to add 1 microsecond to the timestamp x. And we can also use the same date offsets to add a nanosecond. So if we remove the micro and change that to nano, now we are using the nanoseconds to add 1. So pd.DateOffsets, and then we have 10, 20, and it should have added a nanosecond, but it instead added a day. And right now I'm not entirely sure why that is the case. I'll put if I found it, I'll put it in the description of this video. There's another point I want to make here is, if we add seconds with a s, then what we are doing is adding 1 to this 30 seconds right here. 30. So in the output what we get is 31, which is just this one. However, if we remove the s from the second and just use second is equal to 1, then what we are doing is we are going to replace this 30 by 0 1, and as you can see, that's what we did here. So adding a s will allow this code to add 1 to the existing timestamp, and if you remove that s, then we are replacing the value completely from that timestamp. Next, let's look at how we can use roll forward and roll backward. So roll forward and roll backward. And here we'll go ahead and create a new timestamp. Q is equal to pd.Timestamp 2020-07-18 and 10 20 30 dot 001 001 001, and here we are going to use pd.Offset. So the timestamp we have is this. Now if we use pd.Offsets with the s dot BusinessHour, so we are going to use the business hour in this case, and for business hour the standard is it starts at 9 and ends at 5 o'clock in the evening, so 17. So what we are going to do now is use the same values. So start is equal to within quotes 09:00 and end is equal to within quotes 17:00, and here we are going to use forward. So roll forward, and we are going to specify the timestamp that needs to be used for rolling. Here we are going to specify Q. So as you can see in the output, our original timestamp was 18. So if we look at q.day_name, we see that it's a Saturday, and if we add a value here, so let's put this on y and look at the y.day_name. So what we have done is we have rolled forward to business hour. From Saturday we rolled forward to Monday morning 9 o'clock. So that's how we can use business hour along with the roll forward to go to the next business day, the beginning of the next business day. Similar to this, we could also go ahead and change the start and end. So let's try that now. If we create a new timestamp, Q is equal to pd.Timestamp, and here I'm going to keep the same month, and let's say the days against 19, and here the time, let's say 11:00:00 dot 123456001. So that's the timestamp we have, and to this timestamp we are going to use roll backwards now. pd.Offsets.BusinessHour start is equal to 09. So the day starts at 9 o'clock, but then the day does not necessarily end at 5. So if we work overtime, then, or if we leave early, which either case, in this case we'll put 1500 hours. So we are leaving early at 3 o'clock in the afternoon. And if we change this to roll back and we specify the timestamp Q, what we are looking to do here is we are going to the previous day's business hours. So if you look at Q day_name, we see that it's a Sunday. So the output that we would get here would roll back to previous business day, which would be a Friday, and end of that business day would be 3 o'clock instead of 5 o'clock. So let's run this, and we get 17th, and we can check the day name for that, and it's a Friday, so previous Friday, so that's the 17th, and the end of the day was 1500 hours, so 3 o'clock. Now let's look at how we can use normalize. Here we'll again create a new timestamp, pd.timestamp 2020-07-20, again 10 20 30 dot 001 001 001, and let's see the output. That's the timestamp. Now what normalize does is it resets the time to midnight. So if you look at X, and there are ways you can do, you can either normalize before any operation is performed or afterwards. So if we use this normalize before, so if you normalize X, this is what it will do. It will move the hours for that day to midnight. So that's what we have done. Basically we change everything to 0. Now if we add pd.offsets.DateOffset, and here we add microsecond, seconds is equal to 1, then what we are doing is we added 1 here, but then it is not added to the existing one in the timestamp X, because we normalized it, changed it to 0. So this one gets added to 0, and therefore we see 1 in the output. However, if we use the normalize on the timestamp that is created after the operation is performed, then the output is different. So if we run this, we added microsecond to this timestamp right here. Now if we normalize this, then we change the timestamp to 0 after the normalization is done. In this case, it didn't affect the dates at all, but there could be certain situations where normalizing could affect the dates. It depends. Next, let's look at another example where we could change normalized, and let's see if the date can be changed. So I'm going to copy this, create a new timestamp here, and instead of 10 I'm going to put 2300 hours and change the 15, and I won't worry about that, and change this to 15. Now what we have is just 1 second away from the next day. So if we add X plus pd.offsets.DateOffset, and here if we add seconds is equal to 1, we are adding 1 second. So the output now becomes 21, and here to this output, if we go ahead and add normalize, it's not going to change normalize. So here there are no hour or minutes time that can be zeroed. So if we add, let's say 10 seconds, then yes, so we zero the 9 seconds right here. But as you can see, this 10 second made a huge difference to flip the date from 20 to 21. Had we normalized this before, then that may not have happened. So if I remove this, remove that, and normalize the timestamp X before we add it, then we would still be at the day 20, and the 10 seconds would be added afterwards. So that's how normalize could help, especially if you are trying to get a date range. You want the start date and end date to both be at midnights or 00, then normalize would help in that way. that was it for this video. I hope in this video you learned how to use pd.offsets, and also one word of caution as to whenever we are using any of these commands or code, we want to make sure that they work. We want to test it on a small sample. For example, we looked at the nanoseconds, and the nanosecond output was not what we expected it to be. So maybe there's something I'm missing here, but that's just a word of caution to check each code or command that you are trying to use and see if it works the same way you expect it to work, and there are no other rules that need to be in place for it to work in that particular way. Please like, share, and click the bell icon below this video to subscribe. I hope to see you all in the next video. Thank you.